This is that part that people try to run away from. But trust me, they are waiting for you in the university. These parts will wait for you. You know, they are like your bunkies, your bunkmates, your roommates. They're going to be waiting for you in future. So please pay attention. You can't run away from them also. I've tried to simplify it. Unfortunately, we can't meet this weekend. I would have loved that we practice first before our class, my normal arrangement on this. However, also I don't want to rush you too much in class, otherwise you don't really understand. Of course, I cover my syllabus. But if we have to spend one period next time on this first, so you can practice the idea, we will do that before we go to integration by parts. And definite integral can be Tuesday, I don't mind. After all, we have planned for Christmas holiday. We squeezed something in, okay? Now, I've tried to, this note also is self-explanatory. So far, we have done, I can group what we have done in 3 different categories. The integrands that can be integrated directly. When I say integrand, we're talking about the function to be integrated. So when I write integral of this is the integrand. 1 over square root of is the integrand. Okay? So the integrand that can be integrated directly using basic technique, x to the power n. When you have sum, you do term by term. If it is sine, this is what it becomes. If it is exponential, those are the ones that obey the direct rules or techniques of integration. That's one group. We also discover another group of questions that we need to first split into partial fractions. Okay? Then we can use the natural log approach or other approaches, because sometimes if you split into partial fraction and you get 3 plus 1 over x plus 1, that 3 is not natural log. It obeys the direct integration also, right? While the other one obeys the natural logarithm approach. Am I making sense? Then later we realize some functions fail to even obey the first 2. It was because the first technique was not enough. That was why there is need for the splitting into partial fraction to complement that, okay? Then even some integrands say this is not enough for us. Then we have to adopt a technique of substitution. Is that not? Such that when you substitute Krista to be you know she's connected to the second function after you differentiate it. In this case, maybe your connection is the food. Who knows? Anyways, do you understand my point? Then there will be some elimination, some transformation of variable, and that we have just also done in some questions. Then we now realize this is still not enough for some integrands. Oh, we are still not included. Now, let's make it more inclusive. Then another type of substitution was discovered. Because since you cannot say let u be something, and there is something to eliminate, to transform the variable, then we have to find a way out. Then the trig functions was able to help in this regard. Okay? There are different ways of doing this. IB only requires you to learn the one that leads to arcsine, because this is the derivative of arcsine, if you remember. It's connected to the derivative of arcsine. And the one that leads to arctan. Arccos was not specified because arcsine and arccos, you can say the only difference is minus, right? So there's no need to worry about that. The other one that leads to sec, I will only mention it, I won't prove it, I want you to attempt it, but it's not required by the IB. So even if you didn't attempt it, it's fine. But you will still meet it in the university. But the approach is the same. So I said, please listen to this preamble, the reason for using it. If the integrand fails to satisfy the requirement of these 3, requirement of this is that it must be the direct one that can be done, right? Requirement of this is that it must be a rational function that can be split into sum of partial fraction. Requirement of this is that there will be transformation that can be done, such that something will cancel something after you transform du to be something dx. If the function fails to meet this requirement, then check. If it is of the form a squared minus x squared, substitute your x as a sine theta. Is that derivative of arcsine that led to something like this? So substitute a, x is equal to a sine theta. If it is in the form of a squared plus x squared, of course, cos can also be used here. Okay? It's just difference of minors, but we just focus. Even in your formula booklet, this result is established. So nobody will tell you to prove this because it's already in your formula booklet. But you'll be required to apply it. Okay. Then, if you have this, you use sec. This is the one we will not be talking about because it's not required by the IB. But I'm saying it to future economics students, future engineering students, future pharmaceutical students who might be doing some math major or minor and be required to learn calculus 2 in their first or second year. So you don't look surprised when the professor starts talking about, oh, we didn't do this in IB. Yes, it's not required, but at least you have some idea. Okay? Quickly now. We will start by saying, let x be a sine theta. If x is a sine theta, clearly, I want to get something in terms of theta alone first. Clearly, x over a is equal to sine theta, and clearly, theta is equal to arc sine of x over a. Yes? Arc sine of x over a. So let this stop here. Then the original problem, integral 1 over the square root of a squared minus x squared dx becomes the integral 1 over the square root of a squared sine squared theta dx. Oh, before then, since I'm introducing theta, I need to transform my dx to d theta also. Am I making sense? So, even this is not enough. Fine, I've expressed in terms of theta. In case theta comes out later, I know something for theta. Just like the question of the u and 1 plus root x. We didn't establish a result for x, so we had to go back.